This is to graph, same thing as sketch, the curve x equal to 2 sine t and y equal to 3 cosine t for t an element of pi over 2 to 3 pi over 2. So this is more of a straightforward graphing problem. We don't really need to use calculus here because there's the easier way. The calculus method where you find mins and maxes, that's for problems where it's impossible to eliminate t very easily. But here I can eliminate t. Whenever you have the sine and the cosine, you can eliminate t like this. So I'll go ahead and do that first. It doesn't matter which you do first, really. The other thing is to plot some points and curves. But so I'll eliminate t first. Eliminate t. And when you have sines and cosines, here's how you do it. You want to take advantage of sine squared plus cosine squared equaling 1. It doesn't. So I'm going to square both sides to get sine squared and cosine squared. But I could also, I'm going to have to divide. So I could divide first. Slightly easier, I think. So first thing I'll do is divide both sides by 2 on the x equation and both sides by 3 on the y. And then I'll square both sides. I know I wanted to do that to get sine squared plus cosine squared. So squaring both sides, I get x squared over 4 equals sine squared t, and y squared over 9 equals cosine squared t. And then putting those together, I add them top to bottom, and sine squared plus cosine squared, cosine squared t, is going to give me a 1. So together I get x squared over 4 plus y squared over 9. Let's put it over here. X squared over 4 plus y squared over 9 equals 1. Okay, so this may be some review. That's the equation of an ellipse, which is a flattened circle, a squashed down circle. If these two numbers are the same underneath, the 4 and the 9, or say they were both 4 or both 9, then you'd have a perfect circle because you could multiply through by that denominator and get the radius on the other side squared. But since they're different, it has two different radiuses, radii. One is 2 because that's 2 squared, and the other is 3 because that's 3 squared. So the ellipse that describes looks like this. Let's see, I'll put it here. It has an x radius of 2 because 2 squared is equal to 4. And it has a y radius of 3 because 3 squared is equal to 9. And it goes both directions, or all, has those radiuses in both directions on the x and both directions on the y. Okay, but now here's where I don't want to actually draw the whole picture solid line yet, because I still have to figure out what the curve does for the t values that are given. So I'll draw a dotted line for the ellipse, and it's symmetrical, so it goes down there, and it's at the same distance on all sides. So yeah, very light dotted line ellipse there. You might not even be able to see it very well in the video, but it goes both directions out to -2 and down to -3. Now we need to figure out what the parameterized curve does on that blueprint. When you eliminate t, you get a shape of the curve, but we need to actually fill in the actual curve. So for that, we need to plot some points and maybe draw some x and y versus t graphs. So for the points, I definitely want to plot the start and the finish. So I just need to figure out a t for pi over 2. Maybe a pi in the middle would be a good choice, and 3 pi over 2. And figure out x and y for those t's. And then at the same time, I could go ahead and draw the curve for x and y. So the curve for x would be where I put a curve like on a smaller graph. Here's x versus t. And for x, x is equal to 2 times sine t. So that's the same as the sine curve. But it does go up to 2 on the x axis, the output as t. And when t is 0, you'll be at 0. But when t is pi over 2, it'll be at 2. And then here's pi. And here's 3 pi over 2. And that'll be down to negative 2. So that's what the graph of x looks like, and then I can fill those in over here too. It's the same process, finding the points on here. Same thing as just plugging in the pi over 2. Keep looking at that one, pi over 2 to the original equation. So when you have, for instance, pi over 2 into sine, you get 1, and then times 2 gives you 2. And when you plug pi into sine, you get a 0. When you plug 3 pi over 2 into sine, you get negative 1, but then that comes out as a negative 2 because you're multiplying it. And now I'll draw a little graph for the y versus t as well. Here's y versus t. And it's 3 times cosine. So here's what cosine looks like. And since it's 3 times cosine, it goes up to 3 and down to negative 3. And pi over 2 would be right here. And there's pi in the middle at that point. And there's 3 pi over 2. There's pi over 2. And 3 pi over 2. And then you can also use your calculator to check those, plugging them in. Remember to use radians though. Always radians when you're doing calculus, because that's the only way you get the correct derivatives. So this would be pi over 2 cosine gives me 0, and so that's a 0. And then at pi, cosine gives me negative 1, so that's a negative 3, and then back to 0. So now looking at all of this information, I can then draw my final picture. I know the point at pi over 2 is 2, 0. This is now, of course, the x-axis and the y-axis. So there's the point right there for t equals pi over 2, which is the starting point. It can start at any time. I think t is time. Then at t equals pi, it'll be 0, negative 3. So 0 on the x-axis and negative 3. And in between those two times, if I look over here, I have x going down. So x decreases, and so does y. Y decreases from 0 to negative 3. So x is getting closer to 0, and y is going from 0 to negative 3. It's definitely this piece of the picture here. So now I'll fill it in nice and dark and put an arrow on it. And I'll mark the starting point. T equals pi over 2. That needs a label right there. And then after that, it eventually ends up at 3 pi over 2, so you can probably figure out where that is now. Negative 2 comma 0, so negative 2 on the x-axis and 0 on the y-axis. And yep, as you go from pi, where x was 0, x still drops. It drops down to negative 2. But y starts growing again, grows back up to 0. So it fills in this much of the ellipse. A couple arrows just to be sure. And this is the finishing point here. This would be t equals 3 pi over 2. Right there. And right in the middle is t equals pi. You don't have to label every single point on there. That's probably good enough. I can see from here that it's t equals pi is in the middle. So there are lots of things to be correct about this. You have to have the right shape of it. You have to have the right starting point and finishing point. And then you have to have the right portion of it darkened in. It's just the bottom half of that ellipse.